Hello class, today we are looking at the volume of prisms and cylinders. So honestly, this should be a review of stuff you've done in other grades, but here we go. So first, volume of a prism. Volume of a prism is B times H, where B is the area of the base, okay? So this is base times height, but this is the area of the base, not the length of the base. And so since this is the area of the base, that means that the formula is going to be different depending on which kind of prism you have. For example, if you have a rectangular prism, the area of the base is length times width. So length times width times the height. If you have a triangular prism, area of the base, the way I have it marked here, is 1/2 length times width times the height. If you have a trapezoidal prism, it would be 1/2 base 1 times plus base 2 times width times the height. If you have some regular polygon as the base, so say it's a regular pentagon or a regular octagon or whatever, it's 1/2 the perimeter of the base times the apothem, or the way I have it is NSA, so number of sides times the length of the sides times the apothem, and then times the height. Now remember, height is always the distance between the two bases. All right, so it depends on where your base is. So for example, on this rectangular prism over here, if these were my bases, then this is not the height anymore. This would be the width, length times width of my base, and here's my height connecting the two bases. Okay. Also very important to remember, height is always perpendicular to the base. All right. So what we do here, very simple, is still area of the base, whatever shape the base is, find the area of the base, and then multiply it by the height. So here we go. Let's take a look at one. And this is not looking right? This is an oblique prism, okay, which just means that the lateral edges are not perpendicular to the base. All right. Remember, if the lateral edges are perpendicular, it goes straight up and down. Like all of these are right prisms. This is an oblique prism. So what do we do with this? Well, let's pause for a moment. Imagine for a moment that you have a stack of Post-it notes. All right? You can find the area of that. All right? 2 times 2 times 8. Not a big deal. 4 times 8 is 32 cubic inches. What if you take the Post-it note stack and you twist it like this? Have you changed the volume? No, you still got the same number of Post-it notes in this stack as you did in that stack. So it's got the same volume. All right. What this is called Cavalier's principle. And it says if two solids have the same height and the same cross-sectional area at every level, they have the same volume. Okay, so just to put it like this, so these two prisms here, they have the same height, h, and the cross-sections have the same area. So the bases have the same area, and all the way up and down they have the same area. So what that means is that our formula works for oblique prisms just as well as it works for right prisms. That's what that means. So in order to find this, we're still just going to do volume equals area of the base times the height. So on this one, our base, let's get the right angle there. So our base is a right triangle, and our height is 8 meters. The height is not part of the prism, it's way out here, perpendicular to the bases. So area of a right triangle, 1/2 base times height, right? Base of the triangle, not base of the prism. And remember, base and height are always perpendicular to each other, so that means the 5 is the base, 9 is the height, or vice versa, either way. So 1/2 times 9 times 5 times the height of the prism. And so we can just take this and give me my calculator. So 1/2 times 9 times 5 times 8 equals 180. And so there you go, 180 meters cubed, cubic meters. Remember, volume is measured in cubic units, not in square units or just straight units, because it's meters times meters times meters. M times m times m is m cubed. Right. Alright, so let's take a look at another one here. How about the volume of a cylinder is B times H. Notice it's the exact same formula, isn't it? Area of the base times the height. And the reason that the volume of a cylinder is the same as the volume of a prism is because cylinders can kind of sort of be thought of as circular prisms. They're not really a prism. It doesn't have any rectangular faces, but it acts like it. Now the difference here is that for a cylinder, it's always going to have the same base, right? The base is always a circle, and so that means we can take this b and we can change it to just pi r squared, because that is the area of a circle every single time. Unlike with prisms, which could have rectangular bases, or square bases, or triangle bases, or trapezoid bases, so it has all those different formulas. With a cylinder, it's always pi r squared, because it's always a circle. And Cavalier's principle works just as good here as it does with prisms, which means that this formula will work with the oblique cylinders just as well as it does with the right cylinders. All right. Okay, so let's take a look. We have two examples here, and I would like for you to go ahead and pause the video, work out both of these, and then come back and check your work. Okay, you are back, so let's take a look here. Problem A. We've got our formula up here, pi r squared h. R is the radius, h is the height of the cylinder, so we're just going to plug this in. All right, so volume pi times 9 squared times 6. All right, so what we're going to do here, where is my thing? There it is. So that would be, I'm just going to ignore the pi for right now. So 9 squared times 6 is 486. So what that gives me is 486 pi. And if the problem wants the exact answer, or if it says give your answer in terms of pi, this is what it means. All right. So go ahead and do this. It's always easier to just save your pi to the end. It's dessert. It goes last. Because if you have other things going on, it's easier to simplify and deal with things if you leave it in terms of pi. Now, if it wants the exact answer, it says round. Exact answer, it wants this in terms of pi. If it wants it rounded to the nearest hundredth or whatever, all right, then we go ahead and finish it up. And so we can take that times pi, and always use the pi button if you have a pi button. Don't use 3.14. All right, and so there it is. And so our answer is approximately 1,526 and 81/100 cubic feet. Always cubic feet for volume. Okay, so problem B, it's an oblique cylinder, but that doesn't matter. The formula works just the same. So our radius is 4, our height is 7, so we just plug that in. Volume is pi times 4 squared times 7. Put that in the calculator. We're going to do get it in terms of pi first. So 4 squared times 7 is 112. So we have 112 pi. And then we're going to multiply that by pi to get it rounded off. And so we have approximately 351 and 86/100 cubic centimeters. So not that bad. Just take it, plug it into the formula, and get your answer. Okay, so let's take a look at this. Here we have a compound figure. We want to find the volume of this concrete block. So as we see, we have this big rectangular prism, and then we have two smaller prisms that are missing, right? So what we can do is we can find the volume of the entire thing, the volume of these two smaller prisms, and subtract those. Except the formula, if you'll remember, is base times height. So what I can do is I can just find the area of this base right here and then multiply it by the height and just get the volume of the entire thing once. Okay? So let's do that. So the area of the base will be the area of the large rectangle minus these two smaller rectangles. Right? And notice these two are the same, 33 by 0.39 0.33 times 0.39. All right, so there we go. So what we have, area of the large rectangle, so 1.31 feet times 0.66 feet, and then minus the two small rectangles, so 0.33 feet times 0.39 feet. And let's go ahead and take that, put that in the calculator, so 1.31 times 0.66 minus, and I have two of these, so 0.33, 0.33, and 0.39 gives me that. Alright, so now I've got the area of my base, just multiply it by the height. Alright, height of my cinder block is 0.66 feet. So times 0.66 is approximately 0.4. So 0.4 cubic feet, approximately. All right? Doing it like this is quite a bit easier than finding the area of the volume of the entire thing, the volume of this piece, the volume of that piece, and then subtracting it all out. Easier to just find the area of the base. All right? And so what I want you to do is find the volume of this solid. So pause the video, find the volume of this, then come back and check your work. Alright, so let's see how you did. So our formula, area of the base times the height. So my base is this triangle with a square cut out of it. So that's what I'm going to do. Area of the triangle minus area of the square. Area of the triangle is base times height, and I don't have the height. That's okay. So what I'm going to do is I'm going to grab this triangle. I'm just going to pull it out and deal with the triangle for a moment. Okay, so I need this height right here. So I'm going to call it x, not to get confused with the height of the prism. And since this is an equilateral triangle, I know that the height is going to hit here in the middle because it's also isosceles. So this is 5, that's 10. And there's actually a couple of things I could do with this because it's equilateral. Because this is equilateral, I know that this is a 60-degree angle right here because it's always 60 degrees for equilateral triangles. So I could use my trig formula, which is 1/2 AB times the sine of the angle, right? And that would work. I could use that for the area of the triangle. However, usually I'm not going to know what this angle is, right? In which case, that's fine because I can still use Pythagorean theorem, right? Because I know it's equilateral, so I know that if this side is 10, this side is 10 as well. And so that's what I'm going to do here because I can use that on everything. So a squared plus b squared equals c squared. Remember, c squared is c is always the hypotenuse, so that's going to be the 10. A is a set aside here. Notice, again, this is the side of the right triangle here in the middle. It's not the side of the entire triangle because we're just looking at that so we can do this. So we move everything over, and I have that x is the square root of 100 minus 25. So x is the square root of 75. So that I can plug into the formula for the area of the triangle. So I have 1/2 times the base of the triangle, 10, times the height of the triangle, that's right here, so square root of 75, minus the area of the square. And so the square has a side of 3, so 3 squared. All right, 3 times 3, length times width. And let's see, where's my calculator? Let's put that in, move that over. So 1/2 times 10 times the square root of 75, minus 3 squared, which is 9. Alright, so there it is. Boom. So there's the area of my base, and now I need to just take that, multiply it by my height, which was 6. The height of the prism, not the height of the triangle. So times 6. Alright, so 205.81 cubic feet. And there it is. So just remember, volume of a prism or of a cylinder, either way, is just area of the base times the height. all you gotta do. Doesn't matter if it is an oblique prism or a right cylinder, doesn't matter. Area of the base times the height. Height is always perpendicular to the base. It connects the two bases. And if you have a composite figure, just find what's the base and do it with that. All right? So hopefully you found that useful, and I will see you in the next video.